Uh, so it gives me great pleasure to introduce our next speaker, which is Professor David Adger, who is an old friend and a great supporter of the initiatives that we have made in India for a formal linguist, for the development of formal generative linguistics, but also somebody who has the breadth and the width of scholarship, vision, and public intellectual engagement that truly makes him, if I may say so, a very, very cherished friend of Tanmoy's, Hany Babu's, and mine. Formerly, he is Professor of Linguistics at the Queen Mary University of London. He was co-editor-in-chief of the journal Syntax from 2007 to 2013, and is co-editor of Oxford Studies in Theoretical Linguistics. He has published many, many articles and books on syntax, but his latest book, which I strongly recommend that everybody reads, which is Language Unlimited from OUP 2019, explains some of the motivations and ideas of generative syntax in an accessible way. He is a trustee of the English Society and a fellow of the British Academy. He currently holds a Leverhulme Major Research Fellowship and is working on a book about simplicity and syntax. And in just one final note, the fact that his talk today follows the kind of talk that Tanmoy has given. David has been a great inspiration in the way that that many of us look at the idea of variation in syntax over geographical and other and social variables. And like Tanmoy, and there are several younger, I think the second lethal wave of linguists, who look at language as it plays out in society. David is certainly a leader in the field of the study of syntactic variation as well. So over to you, David, because I do not want to stand between you and the audience anymore. Thank you.
Okay, thank you very much, Aisha. I'm going to try sharing my screen. Let's see if it works. Does that look like it works to you guys? Can you see my screen?
Yes, yes, yes.
Wonderful, great, thanks. And thank you very much to the organizers for organizing and putting this this conference together. I think it's a really important thing to have people able to talk to each other in increasingly authoritarian times that we're all living in. But I want to look back to like a little bit of a happier moment. So let's see if I can make this work. So this was one of the first times I spent some time chatting to Hany Babu, which was one of the listens in Kausani in 2009. There's a picture of me looking a lot younger with more hair there. Hany has the same amount of hair, I think. And much of the conversation that we were talking about was about copular clauses and possession. And we were interested in really I was interested in learning about how these worked in Dravidian languages and in many of the other languages that were spoken by students at that summer school. And particularly I was really interested in how to understand the kind of spooky similarities between the way that copulas worked in Dravidian languages and Celtic languages. So I'm just going to give you a taste of that, but that's not really going to be what the talk is about. So here's some of the spooky similarities. So at the top, you'll recognize Malayalam there. And you see that to say I'm a linguist in Malayalam, what you find is the use of the copular verb, arnu, and not the verb, which is more like the verb to be, some kind of more general verb of existence, untu. Okay, and that's how you say I'm a linguist, and you can use one and not the other. But for possession, it's the other way around. So you have a dative subject in 1b, so to me, that kind of thing. And then there's a white car, and then what you see is the use of the other kind of be verb, the exists verb, and not the copula. And if we look now across oceans and continents and language families, we see in two a spooky similarity. So in two, what we see are examples from Scottish Gaelic, spoken in the Highlands of Scotland. And what we see there is, again, two kinds of be-type verbs, one of which is a copula, and the other one of which is more like the verb to be. And at least archaically, you can use the copula to say, I'm a linguist. So it's can yichimische, so what you see in 2a, and you can't use the other verb. So ha can yichimische is just totally ungrammatical. But if we turn and we look at possession, then what we see is that you can use the be exists type verb and you can't use the copula. So ha car gyal akam, I have a white car, and not is car gyal akam. So, you know, there's a kind of interesting commonality there, right? Between how these concepts are expressed in terms of the grammar of these different languages. So I've given you a little table there. You don't need to spend too much time in it, but you can see that if we look at the column that's got noun phrase predication, so I'm a linguist, at the top, aside from the order of the words, it's the same. So you've got subject NP, predicate NP, and you can have the copula, but not the verb to be. And with possession, you've got a subject NP, and you've got an object NP, and you can't have the copula, but you can have the be. The word order is totally different, but the same kind of similarity is emerging. And, you know, I've given you here a quote which goes back to 1955 from Noam Chomsky's Logical Structure of Linguistic Theory, which really is about, still a very true statement about how generative grammarians think about what they're doing when they're studying language. So Chomsky says there, we can generalize the notion of generalization itself to cover the situation where we have a set of statements which are identical in part. Then the common substatement can be extracted out and stated only once, applying to all elements with a consequent shortening, that is a simplification of the grammar. Now, Chomsky there was talking about the grammar of one particular language, English there. Logical Structure of Linguistic Theory provides a transformational analysis of English, but the same point holds when we look at different languages. What are the commonalities that can be extracted that allow us to see what is truly universal to human beings there? And I want to explore in this talk not the solution to this puzzle, right? This puzzle that I've just given you about Gaelic and Malayalam, I certainly never figured out the answer to it, but rather the way that generative grammarians approach that puzzle and the question of how the notion of shortening or simplifying our grammars, our theories of language, connects with the notion of specifying what is common to us as human beings and how we speak language. Okay, so this is a much more technical talk than Tanmoy's was. I really enjoyed Tanmoy's talk. I learned an enormous amount from it. Here, there's going to be a bit of maths and stuff, but I will not spend too much time on that. I'll try and focus on the more general idea. Okay. All right. So let's just move on. All right. So the questions. So what we just saw there was the spookiness. There was about the partial similarities, and so there's a question, right, which is where do these partial similarities come from? Now, if we're looking at particular grammars, you can imagine it might be learned, but clearly they're not learned in the case that I just gave you, because we're looking at two entirely different languages. So the similarities, putting aside bilinguals, I don't know if there are any Scottish, Gaelic, Malayalam bilinguals, but putting aside those, there's no way that these similarities could emerge from learning. The similarities seem to be tied to grammar, okay, and grammar's link to meaning. Now, the classical generative answer to this question is that there's some universal system, universal grammar, that points we humans, as we learn a language, towards a particular kind of grammar in the end, a particular outcome. And figuring out what that universal system is the thing that allows us to account for the significant generalizations that are around, both about particular grammars and about the human capacity for syntax in general. Now, if we look back, way back in the early days, the way that Chomsky, at least, and he was the person who was really doing this then, understood what we might think of universal grammar now, although that term would be anachronistic looking back at it, is that universal grammar was sort of seen as a simplicity metric. So I'll give you an example here. So these, what you see in 3A and B, are two phrase structure rules, where phrase structure rules are ways of stating generalizations about a grammar. So these are just given as schemas, but you can see in 3A, we say that whenever you see a category X, then you can say that that category X can be rewritten as or understood as W, Z, and Y, okay? 3B says also when you see that category X, it can be understood as W and Z, that is a constituent containing W and Z. Now you can see that those two grammars, sorry, those two rules are very similar to each other, right? So you can extract out that similarity and gain a generalization, which is that Y is optional in the context of W followed by Z, right? And you can, and Chomsky provided a number of conventions that allowed you to shorten these phrase structure grammars. And the way that you shorten them gives you a simpler grammar, and it also captures a linguistically significant generalization. In this case, that Y is optional in these particular contexts. If we compare 3A and B with 4A and B, okay, what you see is it says X is a constituent containing Y, Z, and W, and X is also a constituent containing W and Y. But there's no way of abbreviating those two rules into anything simpler, right? So what that tells you is that the kinds of rules that are in 3A and B that you can abbreviate are the kinds of rules that we expect, in a sense, to see in grammars, okay? These are the kinds of grammars that are preferred. So Chomsky referred to this idea that we have simplicity ranking grammars in terms of which one is better as an evaluation metric. And you can imagine that evaluation metrics are incredibly useful for learners of a language, right? Because they push that learner into smaller and simpler grammars. So that was the early days of thinking about universal grammar. What was universal was not the rules in any sense, or any constraints in the rules, but rather what was universal is this way of making grammars simpler. And that would be the thing that all humans would have in common. Now, as time went on during the development of generative grammar, then what came later was much more content to what would be in universal grammar. So that's the notion of thinking of universal grammar as actually restrictions on rules. So you can learn the rules, but these rules would be restricted in some sense, okay? So for example, throw yourself back to your early transformational grammar syntax class, and you might remember a rule called WH movement that for some languages says when you see a WH phrase like who or what, where in a sentence, then you can also have a sentence where that same WH phrase is moved to the start of the sentence. And that's what the rule in 5 gives you. Now, it turns out that actually, if you let that rule in 5 just run, it will generate for you all sorts of wrong structures and wrong sentences. So even very early on, the suggestion was that these rules came along with constraints, okay? So for example, the rule in 5 would be constrained by what's called the A over A constraint, which you see in 6. It would say if a rule refers ambiguously to two elements, call them A, right? Two elements of the same category, then it must apply to the larger instance. So for those of you that know, if you think about the rule of WH movement 5, that would mean whenever you see that applying to a clause, it would never really allow you to take that WH across a comp, across that comp thing. It would sort of cause you to stop in the middle, okay? We don't really need to go into that, but you can see there'd be a constraint on the rule. Now that in the end became basically what generative grammar became about. Not so much the rules as a very rich set of constraints on how the grammars of human languages used to work. So UG, rather than being seen as a set of ways to make grammars smaller and therefore simpler, right? A simple way to make grammar simpler would lead to a rich, complex way of attempting to make grammar simpler. So UG was then seen as a set of complex restrictions. So, you know, it turned out over time that when people tried to simplify one part of the grammar, that would end up leading to complexity elsewhere. So you could simplify the rule system, like we just saw, but then you get complex constraints. And in general, the way that those constraints were stated was what you might think of as representational. You would just write down the constraints and say, there's a set of constraints, essentially knowledge, right? The speaker's knowledge of their language that would restrict what the possible rules in their language did. So there's, I mean, that became a very, very successful way of understanding the massive complexity. When you look at different syntax of different languages, you would say, well, there's something similar to the constraints, and then there are points where those constraints can be loosened. And that led to what's known as the principles and parameters approach to universal grammar. Now, there is a cognitive scientist, Zeno Polishin, who suggested that generally constraints should not be stated as essentially just, here's the rules, here's a bunch of constraints, and now we've done our job. What he suggested is that the constraints should emerge from the architecture of the cognitive system, not from simply writing them down, okay? So we could ask ourselves, and this is known as Polishin's razor. It's like Occam's razor. It says, represent as little as possible, okay? Now, this could lead us to ask to what extent it might be the case that contentful restrictions on universal grammar could emerge from a simple system. So rather than stating them in this complex fashion, to what extent could all of these complexities, all the complex constraints, emerge in some sense from simplicity? And if so, what kind of simplicity might this be? Okay, how might it connect to the notion of evaluation metric that was around at the very start of generative grammar? So this is kind of what the talk's about. It's not really about you know, particular data, although we will see some data. It's really about this balance between when we think about how to understand what is common to human beings in terms of a grammatical capacity, how much needs to be stated complexly, and complexly is not a great word, but you know what I mean, and how much can be extracted out and made simple. So I'm not going to, that's what we're going to talk about. All right, now I'm going to give you a little bit of maths. You can turn off if you don't like it, but it's kind of important for where we're going to go. So if we a system of objects, of some kind of abstract set of objects from a mathematical perspective, then you can see a system of objects as consisting of the objects, right? You need to generate those, and then some set of primitive objects, and then some set of computations which applies to the primitive objects to give you the objects, and then applies to the objects to give you more objects. So a really simple case of a system of objects from mathematics is the number series, 1, 2, 3, 4, 5, etc. Okay, and that can be given in this way by saying, okay, well, we've got D, which is the system of objects. We've got one primitive object, call it 0, and we've got a computation on 0, which basically appends a stroke to it. Okay, and then what that does is, of course, gives you the entire system of numerals. So you've got 0, you've got a computation on 0, which gives you 0 dash. Now you can have a computation on 0 dash, which gives you 0 dash dash, and then 0 dash dash dash, and so on. So you can see this abstract system will generate for you something which you could understand as, for example, the natural numbers. If you assume that 0 is effectively 1, 0 dash is 2, 0 dash dash is 3, or as the integers, you take 0 to be 0, and so on. Okay, there's lots of ways you can see the system of abstract objects actually being cashed out as real things. Well, if you, depending upon your view of whether you think numbers are real things. Now, this sounds like kind of maths, but probably those of you that have done a bit of syntax will think, oh yeah, I can kind of see where this is going. But before we get there, I just want to point out that, actually I should just go back a little bit, that really quite crucially, F here, which is part of what a system of objects is to be understood as, in this case, a set of operations or computations on the basic objects. Now, if we think about what computation is, again, we can go back to Clooney's classic 1952 book and think about what computable function theory is. Okay, this is a long cry from the sociolinguistic stuff that we were talking about earlier on, but I think, you know, I'll try and bring it back around to these questions by the end. So classical computable function theory, I'm not going to go through this, but what it basically tells you to do is to come up with a set of as minimal operations as you possibly can, and then as minimal modes of combining those operations as you can. So for example, a minimal operation might be any number, anything you get, map it to 0. Or anything you get, map it to itself. Or for numbers, any number you get, map it to that number with a dash after it. So you can see these are very, very simple operations. And then those operations effectively can combine. So for example, you could take, you know, 0, and then you could take the successor of 0, which is the successor of 0, right, which is 0 dash. And you can take the outcome of that, 0 dash, and then use that as the input to the successor, giving you 0 dash dash, and so on. So you can see how this composes various objects together to give you more and more and more objects. Now, notice that what's really crucial in here when we do this is you kind of need to have a memory for what you've already done. That is, you've computed something, the successor of 0, and you know what that is, and that's 0 dash, and then that is then used as the input to the next computation. Okay, so you need some kind of memory to make these computing systems work. Okay, now you might be thinking, David, you were here to talk about linguistics. What is going on? So the relevance to this, for some people, might be kind of clear, right? Syntactic structures have properties that are actually extremely well modeled by the kind of abstract systems and computable abstract systems we've just seen. So the syntactic structure of a language can be thought of as an unbounded collection of structured expressions of that language. And we saw from Tanmoy's talk just now how complex those structured expressions could be, right? They can involve agreement with subjects and with objects and with allocutive addressees and so on. They can be pretty complex, right? And they build from primitives into more and more complex structures, and it doesn't seem that there's any end of them, right? The primitives are basically things that we as linguists know and love, morphemes, words, categories, and so on. And what we do is we combine these in particular rule-based ways into larger and more complex expressions. And this, of course, is what gives me right now the capacity to say all the things I'm saying to you. Okay, it's what gives us the capacity to draw back to the kind of theme of this conference, to actually have free speech in the first place. So there's something very common to all humans, which is this capacity to productively and creatively say what we need to or want to say. Okay, so from this perspective, a grammar really is a computational procedure. And so we might expect, if we're thinking about simplicity, we might expect a grammar to involve the same kind of simplicity we see in the theory of computation. All right, I'm giving you guys a moment to breathe because that was kind of a bit complex, and now we're going to get even more mathsy. I hope the sociolinguists will forgive me here. So if we take our generative grammar up to not quite the current day, but the most recent incarnation of formal grammar, of generative grammar, then something like the minimalist program, then one of the real claims of that is that there is a fundamental operation, okay? That fundamental operation is called merge, and what it does is it takes two units and combines them into a more complex unit. And the idea is that this very simple operation will give you the kind of complexity you need for all of syntax, okay? It's probably not quite enough, but it will get you a long way. So the way that Chomsky talks about this is in a bit of a mathematical way again. He defines the notion of a syntactic object. That is, that's not object in terms of subject and object, that's just thing, right? So a syntactic thing, you say, if something, alpha, is a lexical item, is a word, then that alpha is a syntactic object. It's a thing, okay? And if alpha is a syntactic object and beta is a syntactic object, then the merge of these two is also a syntactic object. And you can see how that allows you to compose the input to merge with its output. So then you've got two syntactic objects. The merge of these two things is just the set containing them. Now, from this very simple definition, you can see it's a computational definition, right? It actually gives you a very rich set of derivational types. It gives you a rich set of objects, of expressions. So it gives you what Chomsky calls external merge. Have a look at 14a here. We've got some A and B that we've already built using merge, and we've got some C. Now A and B is a syntactic object, C is a syntactic object. So our definition says that 14b, which is an object containing C and AB, that's a syntactic object. And you can imagine you can keep adding in, and that will give you more and more stuff as long as you've got the lexical items to do it, okay? Further, you could have taken A and B and C and A and B and then merged those two together to give you a yet more complex object. So there is no end to the complexity here. Chomsky also points out that this same definition will give us something that looks very much like what we see with the WH movement examples or rules we saw before. So if you take something like David read which book, you can also say, which book did David read? Okay. Chomsky's idea is that you start off with something like David read which book. Now, the whole thing, David read which book, is an object, syntactic object, but also which book is a syntactic object. So you can merge which book with the whole thing, giving you which book David read which book, and then use some other stuff to make it what you want in the end. Okay, so that's what used to be known as movement, but it just comes from merge. Okay, so Chomsky often calls this internal merge now. All right, so we've got a very simple system. We've got some basic primitive objects, things in the lexicon. We've got a very simple operation, merge. That gives us a set of expressions which are of the right kind of type to give us what the expressions of a human language look like. They're unbounded, you can have as many as you like. They're structured, we know syntax is structured. They involve displacement, which we know syntax seems to have. And you can imagine, although this doesn't say anything about it, that they're good inputs into the other systems, into systems that allow you to order words and systems that allow you to put the meanings of words together to create larger meanings. However, this system also gives you a lot of other stuff. I won't go through this very much, but you can easily use this system to actually have you take some object and merge something down inside it. So downwards movement, what we think of as downwards movement. For those of you that have done syntax, you'll know that that's just a no-no, okay? Human languages don't seem to have much, if any, downward movement. There are some analyses, but most people think that they're not the right analyses. It also allows you to have something called late merge, which I'm not going to talk about. And it also allows you to have something called parallel merge, where you have essentially one constituent and then you merge from inside that constituent to another constituent, which is just somewhere else entirely, okay? Now, Chomsky placed various conditions on merge to rule all these things out. But the point I want to make is that actually the system as it stands is a very simple system, but it gives you out too much. It's unconstrained and it needs to be constrained. And that's what Chomsky did in earlier work. He added constraints to it. But if we think of Polition's razor, ideally, we want a sort of WYSIWYG system. We want to just generate the right things straight off, right? Rather than generate them and then filter them all out. Okay, so parallel merge, do we need it? I mean, maybe these extra systems like these ones I just told you about here, maybe they're great. Maybe we really do need them. In fact, lots of people have argued that this is great because actually merge gives you loads of extra stuff and we can use that extra stuff. So for example, let's take a case like, what did Lily catch? Lily's my cat, you might see her if she gets hungry later, and Dodger eat, okay? So that's next door's cat. And you can see that there's one thing there, what, but Lily's both catching it and Dodger's eating it. Similarly in 19, what did Lily play with while eating? Lily's playing with something and eating that same thing, okay? Now you can generate these kinds of structures in the following way. What you do is you use merge to build eating what, right? Once you've built that, you can then build something else entirely separately, play with, and then you merge what from eating what with that play with. So you get play with what while eating what, so that what is effectively shared across those two sentences. And then you put the whole thing together, take that single element what and create the structure in 19. So Jairo Nunes argued that that was the right story, and Barbara Chitko has also argued it, and lots of other people. Okay, so maybe we just want these extra kinds of derivational structure. Right, I think we don't. I'm actually going to skip this slide, I think, just for in the purposes of time. But basically what it shows is that if Chitko and Nunes are right, what in those two different positions in the tree is the same thing. So it should behave exactly the same, okay? And it doesn't, it behaves differently. And that's what the examples in 21 and 22 show you, but I won't go through them, okay? I'll just ask you to take my word for it, and you can look back and puzzle it out yourself later on, okay? But crucially, what we expect to see is something that's the same, and what we don't, and that's not what we see. I'm going to briefly go through some really cool examples discovered by Doreen Georgi from a bunch of African languages, one of which I'm working on myself just now, the language Kedaraka. Now, some languages, when you do a long distance WH expression like, what did you think that David was reading? So you've got an extra clause in there. What did you think that David was reading? An extra clause. What they do is they change the way the intermediate clause is introduced just when you've done that WH movement. So you get WHA, did you think, and then some special form of that. So you don't just say, what did you think that David was reading? You get, what did you think that bing David was reading, where that bing is a special kind of that. I'll show you some examples of this. Now, what Georgi notices is that these languages provide us with a means to distinguish the parallel merge derivations of across the board that we just talked about from non-parallel merge ones. And she basically shows you that the parallel merge ones lead to the wrong expectations, right? Why is that? We'll have a look at 24. So 24 is a structure for something like, what did you think that David read? And did you say that Mary loved? Okay. What Chitko notices is that if there's just one thing, then the complementizers, the words like that appear all the way through this, should all be the same. Okay? Because it's just the one same thing that's moving past them. They're all inside that movement in a sense. Right? And if we don't get that, that says something else is happening. Now, as you can imagine, I wouldn't be taking you through all this complexity unless something else was happening. And so what actually happens when you look at real languages is that we get a different form of the complementizer after the and. And that says that that complementizer is not inside the movement, it's something else, okay? So I've got an example here from Bully. I'll give you the one from Kitaraka. So if you have a look at this, this is, what did Mfana think that Maria bought and John broke, right? Now, if the word what was the same object of buying and breaking, then basically we should find the same complementizer all the way through, and we don't, okay? So it turns out what Georgie shows is that these, in this very tiny, weird little corner of the grammar, these, we don't get the expectation you would get if you had parallel merge. Okay, for those of you that have given up on all of this, here's the takeaway message. This generalization that Georgie came up with, the evidence for this generalization in the input to kids is negligible, right? You need to have a WH movement configuration, and you need to have a coordinate structure, and it needs to be embedded. That just is not the way that people are chatting to each other, right? I mean, you know, for those of you that have done sociolinguistic corpus work, it's hard enough to find some negations in corpora, right? Trying to find that, you're not going to get them, and kids are not going to get them. So if parallel merge is really given to you by universal grammar in the way that you might expect it to be if merge is what's given to you, okay, we should expect the gaps to behave identically. We should not expect to see what Georgie found. There are two possibilities here. Something else is ruling that out, or parallel merge just isn't in the kid's universal grammar. It's not something that the kid can do, okay? If that was the case, we would expect to see what Georgie found, okay? So that's the really crucial thing. It actually looks like the data, if you look at languages that are really, you know, not the normal languages to look at, you look at them in detail and you look at quite complex things in them, you can find out really interesting things about what is common to humanity in terms of universal grammar. So I think I'm quite convinced by Georgie and what she's shown here. Okay. Now we could rule this out. I won't take you through this, but for example, in a well-known formalization of minimalist syntax, Collins and Stabler just have a special thing that says, and don't do parallel merge. They just rule it out by fiat. But that leaves open the question, why not rule out other things by fiat? Why have internal merge at all, right? Why does language look the way it looks? Right? So this is actually what's really behind Polishin's razor, right? That you don't want to just be ruling things out because you're not really getting a deep explanation there. There's a more recent proposal. So Chomsky has noticed this problem for a few years and has been arguing that actually there's another way of ruling it out. I'm not going to go you through that either, unless you want to ask me in the questions or email me about it. But I think that Chomsky's mode of ruling this out ends up actually being fairly complex, right? I mean, really the crucial thing is the way he rules out parallel merge also really rules out internal merge. And then what he needs to do is rescue internal merge being ruled out by something else. I actually don't think that works out if you work it through. But you can see that we've now got two things going on, right? We've got not just the system doing it, but the system generating the right thing, but something else also ruling it out. So I'm not going to take you through this, but I think those proposals also don't work. I'm going to give you a different set of proposals, which are here. Okay, and the proposals are very much inspired by Polishin's razor. So the constraints come from the architecture. Now remember, what we're dealing with here is a computational system. That's what I took you through all that horrible maths for, right? It's a system that involves operations who store their results and then reuse them. That means there's a memory associated with the operations, okay? And my argument here, and I'll just briefly take you through it, my argument is that it's the architecture of that memory that's crucial. So this is a paper I wrote horrifically 4 years ago now that I never did very much with. I just kind of put it on Lingbuzz, and then I became dean and wrote Language Unlimited, which is much more accessible than this talk, let me tell you. So my attention got taken elsewhere. I'm coming back to it now. So my idea then is that actually, when you build syntactic objects, merge, that operation merge, takes place in a very small separate memory buffer, right? Which I've called the operating space. So for those of you that know anything about computers, the way that a computer works is you have long-term memory, and that's your RAM. And then you have the stuff you're working with right now, okay? That's called your cache. But you don't really do much with the cache. You generally don't operate on the cache. You just put all the stuff you need there. And what you operate on is called a register. You copy things into the register, and then you do the operations on the register. And the reason to do that is it makes for a much more efficient machine. So I'm blatantly stealing this idea, basically, and suggesting that something like that, obviously not exactly like that, but something like that is what's going on in the case of merge as well. We have a resource space where we put the things we're working on, and we store the results of our operations. And we have another space where we put the things that we want to operate on. So the idea will be that by having 2 bits of memory, we will end up ruling out parallel merge. Okay, and let me show you very briefly how this works. So briefly, the resource space, right, is what Chomsky calls the workspace, and it can access the lexicon, right? And it can also access the output of the operating space. This resource space is what's called a multi-set, so that just basically means a set. You can have repetitions. So for example, if you're going to build a sentence, the dog chases the cat, you can have 2 this in there, okay? And then once you've done your operations, you put the outcome back into the resource space. So for example, if you were to build the constituent, the dog, in the operating space, you could then put that back into the resource space, and you'd get more structure in the resource space. Eventually, all the stuff in the resource space gets used up, and you get a complex syntactic expression. Unlike the resource space, the operating space is limited in size. The resource space has no specific limit in its size. Okay, you can put what you want into it, but the operating space is a 2-cell memory, which I just notated here as a set with 1 and 2. It's a set, not a multi-set. Okay, that's for reasons we don't need to care about too much here. And what happens is that merge applies to the operating space, taking the 2 cells and creating a new object. And then that gets written back into the resource space, clearing the operating space out. So you can see how this is like a 2-stage operation. Whenever you want to build something, you copy the stuff into the operating space. Merge is incredibly trivial there, because it's like just 2 cells, and then you write it back. Now, with that architecture, okay, that's just what I've said, okay? And with that architecture, I'm going to skip these 2 slides and come back to them. With that architecture, you can actually do the kinds of derivations that Chomsky wanted for external merge and for movement, okay? So let's look at a resource space containing the, cat, jump, and maybe some other stuff. What you would do in this case is you would take cat from the resource space into the operating space. Then you would take the from the resource space into the operating space. Then you would merge the cat, the and cat, giving you the cat. And then you would take that from the operating space and put it back in the resource space. And then what you get is a structured resource space, looking like just what you see after 36. So you can see how that's the same as Chomsky's external merge. What about internal merge or movement? This one looks a bit more complicated, but I maybe should have done this as a tree so it looked more familiar, but I've done it as a structured object. So if you have a look in the resource space, it's really just got one thing in it, this complex object, which is basically what syntacticians think of as a clause with the subject, the cat, low down in that clause, okay? The idea would be that you take that whole object from the resource space, put it into the operating space. Then inside that operating space, you look down inside that object, you find the cat, and you put that in the other cell of the operating space. Now you've filled all the cells in the operating space, you do your merge, okay? And that gives you the horrifically complicated looking object you see after the equal sign in 37C. And that's a case where you've moved the cat from one position in structure to a higher position in structure. What you do then is you've got the object the merge is created and you copy that back into the resource space, and there you have internal merge. Okay, you're probably all exhausted, but luckily we've got very little to go. Now, let's see how parallel merge is now unstateable. So here's the sentence. Guess what Artemis recommended and Tonius read. You can see I gave this talk once in Berlin, where Artemis Alexiadou and Tonius Veenstra were both in the audience. So I did that for them. I should have put Tan Noy and Ayesha instead. So the first thing you would want to do is get to the point where your resource space contains recommended what, because that's what you're going to need. You're going to need recommended what, okay? Then you're also going to need to merge that what with read, okay? So you select recommended what from your resource space, and you put it in one of the cells of your operating space. Now you're going to need to merge what with read, right? So you select read from the resource space and put that in the other cell of your operating space. Now what you need to do is merge what from inside recommended what with read. So you take what from inside recommended what and you merge and you copy it into, put it into the other cell in your operating space. But now you're buggered, as we say in Scotland, because you can't actually merge anything in there, right? You've used up both cells, so the system crashes. It turns out it's simply impossible to do a parallel merge derivation with this memory architecture. It also turns out, and I won't show you how, that it's impossible to do the downward movement one and also the late merge one. And notice that what's happened is that this has come from the architecture of the system. So I know this has been a rather complex talk in terms of syntactic theory. Ayesha said, oh, and David's also done sociolinguistic work, which I have, and maybe that would have been a better choice. But I do think that there's something really important here when we think about how the formal parts of grammar connect with what is really a very human thing, our capacity to express ourselves and to express ourselves both in terms of the variable systems we use in sociolinguistic terms and in terms of our political capacity to say what we need to say when we need to say it. The overall system I've suggested is that there is a restriction on how we human beings do this, okay? And that restriction still allows us to say the things we need to say. It just allows us to say them within the confines of human syntax, the thing that binds us together. So there's two memory stores, and select this thing that writes between the two memory stores, and we rule out parallel merge from doing that. More generally, I want to go back to the theoretical question we had, which is that simplifying a syntactic system often leads to an increase in descriptive power. You end up, removing all the restrictions you had before, and you get more and more types of structure. And then you have to add in the restrictions, which then makes the system more complex. So what I've done here is I have complexified the system. I've added in an extra layer of memory. But within that extra layer of memory, I've reduced the computational complexity. Merge itself operates over a much smaller domain, okay? And the information that's available at the stages of the computation is thereby much limited. And that is a system we know broadly that makes computation more efficient in man-made machines. Okay, so I think there is a way, although it's quite difficult, to look at issues of how computation works and limit the way that universal grammar works on the basis of that, which is one of the things that Chomsky has been pushing for minimalism for a while. Now, I've done it in a different way from the way that he's been pushing recently, but I think you can see the broad similarities in that. Okay, and that's my general conclusion. And I want to say thanks again to everyone for organizing this. And I hope, even though it was probably a lot of information and complexity for this time of the day for you guys, at least that you got something out of it. Thanks very much.
Thank you very much, David. I'm really sorry, and I have many questions myself. I typed one in and then I said, oops, we're going to have no time for questions. But maybe people could put their questions in the chat and continue this discussion elsewhere, because we would really have to move to the next section because our chair is waiting and we have some messages.
Of course.
But is it okay, David, if we put some questions down in the chat and then
I'll reply to them while we're listening to the next session. Yeah, absolutely. Yes. Thanks very much for your attention.
Thank you so much, David. It was a lovely talk. Thank you.